Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Our chapter today is about relative positions. Now f and g are two given functions, and c and g are the representative curves of f and g respectively in an orthonormal system. So c is the representative curve of f and g is the representative curve of g. Now, to study the relative positions of C and G, apply the following steps in order. So first, we have to find f of x minus g of x. Remember, we are finding the relative positions of C and G. So we find f of x minus g of x. We study the sign of f of x minus g of x. Now, if f of x minus g of x is greater than 0, then we can say that C is above G. C is the representative curve of f, and G is the representative curve of G. Now, if f of x minus g of x is equal to 0, we can say that C cuts G, and if f of x minus g of x is less than 0, we can see that, and if f of x minus g of x is less than 0, we can say that C is below G. So in fact, the relative positions of C and G depend on the sign of f of x minus g of x. Greater means above, equal means cuts or intersects, and smaller means below. So this is what we have to remember. We find the sign of f of x minus g of x less than 0 means C is below G, equal to 0 means C cuts G, and greater than 0 means C is above G. Now let's take an example. F and G are two functions defined as follows, and C and G are their representative curves. The question is to study the relative positions of C and G. Now we find f of x minus g of x. We get this expression, and we need now to study its sign. Remember, to solve an inequality which is not of degree 1, we have to compare to 0, we have to factorize, we have to find the roots, to construct a sign table, and finally to find the result. Now the roots are x equals negative 1 and x equals 2 from the numerator, and x is never 1 from the denominator. Now we draw this sign table. Remember again and again, this is a polynomial of degree 2 having two roots, so we apply same, opposite, same, and this is a binomial of degree 1, so we apply opposite, same, and this would be the result of f of x minus g of x. Now let's see how do we study the relative positions. Because f of x minus g of x is negative, we say that C is below G, and then C is below G also here because the difference is negative. Here we have C is above G, and here C is above G, and we can say that C cuts G at x equals negative 1 and x equals 2, and this happens because at x equals negative 1 and at x equals 2, f of x minus g of x is 0. Now let's see this application. We have f of x and we have line D. Now the question is to study the relative positions of the curve and the line. Now try to pause the video, find out the answer, and then compare it with the given answer. Now here f of x minus y of D is x squared minus 1, and it's easy to study its sign. The roots are negative 1 and 1. Put this table, the sign table, same, opposite, same. So here we can say that C is above D. Here C cuts D. Here we have C is below D. Here C cuts D. And here C is above D. Now it's enough to say that C cuts D at x equals minus 1. But if we want to know the point of intersection, we can substitute minus 1 either in the equation of the function or in the equation of the line. Now we're going to see the relative positions of two curves graphically. We have this figure. The red curve is the curve C, and the blue curve is the curve G. And they intersect at A and B. The two curves intersect at A and B, and we know that E is the point whose abscissa is 1.2 and whose ordinate is 0. So we can say that the abscissa of B is 1.2. Let's see the question. The question is to study the relative positions of C and G. Now here it's easy because it's a graphical approach. So we can state that on minus infinity minus 1, you see from when x varies from minus infinity to minus 1, you can see that the red curve is below the blue curve. So we can say that C is below G. In other words, f of x is less than g of x, or f of x minus g of x is negative. On the interval minus 1, 1.2, we can see from here that the red curve is above the blue curve. So C is above G, so f of x is greater than g of x, or f of x minus g of x is greater than 0. And when x is exactly negative 1, this is negative 1, or x is exactly 1.2, you can see that the two curves intersect, or they cut each other, and we can state that f of x equals g of x. Now this is what we call a study of the relative positions, but this study also could be expressed in a table. So f of x minus g of x from minus infinity to minus 1 is negative. That's it from here. And then between minus 1 and 1.2 it's positive, and between 1.2 and plus infinity it's negative. So here C is below, C cuts, C is above, C cuts, and C is below H. Remember again, it's enough to write the answer verbally, but it could be expressed also tabularly. Now let's see an application. We also have here two curves, the curve C and the line D. The question is to study the relative positions of C and D. Let's analyze it a little bit. We can see that the curve and the line intersect when x is negative 1, and they also intersect when x is 0. Thank you.